The most indestructible boat engines ever built are hiding in plain sight at your local marina. Imagine owning an outboard so bulletproof that mechanics joke it'll outlive your grandkids. Yet here's the kicker. Some of these legendary power plants have fatal flaws their manufacturers desperately don't want you to discover. We're diving deep into the controversial world of marine reliability, where a single gasket can mean the difference between a family heirloom and a $30,000 paperweight. From diesel monsters that laugh at abuse to gas guzzlers with cult followings, prepare to have everything you thought you knew about marine engines turned upside down. Let's kick things off with what many consider the Toyota Camry of outboard motors, the Yamaha F150. This 2.7-litre inline-4 has earned a reputation that borders on mythical among fishing guides and charter captains. We're talking about an engine that routinely hits 5,000 hours without major surgery, and that's with commercial abuse that would make most motors cry for their mommy. What makes this thing so special? Well, Yamaha basically over-engineered the hell out of it. The F150 features a dual overhead cam design with 4 valves per cylinder. Fancy stuff that usually belongs on sports cars, not fishing boats. The real secret sauce, though, is Yamaha's proprietary YDC30 alloy that resists corrosion like a Teflon pan resists eggs. They call it Ultimate Corrosion Protection, which sounds like marketing BS until you crack open a 10-year-old F150 and find internals that look factory fresh. Here's where it gets interesting. The F150's displacement and architecture make it incredibly understressed at its rated output. While some manufacturers push their engines to the limit, Yamaha left plenty of meat on the bone. This conservative approach means components last longer, run cooler, and tolerate abuse better than higher-strung competitors. The downside, these things are thirstier than a marathon runner in Death Valley. We're talking 15 to 16 gallons per hour at wide-open throttle. But hey, when your engine runs forever, who's counting fuel receipts? The F150 also weighs in at 487 pounds, making it a bit of a porker compared to some competitors. But that weight comes from overbuilt components that refuse to break. Before we dive into Mercury's engineering marvel, if you're finding this deep dive into marine reliability helpful, hit that subscribe button and ring the notification bell. Trust me, what's coming next about the Verado will blow your mind, including a dirty little secret about the early models that Mercury tried to bury. The Mercury Verado 300 V8 represents everything that's right and wrong with modern marine engineering. When Mercury introduced this 4.6-litre supercharged beast, they basically said screw it to conventional wisdom and strapped a belt-driven supercharger to a V8. The result? Whisper-quiet operation that makes electric motors jealous and acceleration that'll rearrange your internal organs. The newer models, post-2018, are absolute tanks. Mercury learned from their early mistakes, and boy, were there mistakes. The pre-2018 Verados had supercharger drive issues and oil consumption problems that made grown men weep. We're talking catastrophic failures at the worst possible times. One captain I know had his blow up 40 miles offshore with a boat full of paying customers. The warranty claim took months to resolve. But here's the plot twist. Once Mercury fixed the supercharger bearing issues, upgraded the oil pump and improved the cooling system, these engines became virtually indestructible. The new versions run cooler, last longer, and deliver power smoother than silk. The advanced midsection, AMS, actually isolates the powerhead from the midsection, reducing vibration by 50% compared to traditional mounts. The real party trick: these V8s are naturally balanced, meaning less vibration than their inline-6 competitors. The counter-rotating crankshaft eliminates primary vibration forces. Your fillings will thank you after a long day on the water. At 600 pounds, it's heavy, but that weight includes the most sophisticated engine management system on the water. Now we're venturing into controversial territory with the Evanrude G2. Yes, I know Evanrude went belly up in 2020, but hear me out. The G2 was a two-stroke direct injection marvel that was decades ahead of its time. The problem? It needed more maintenance than a supermodel's hairdo, and the market wasn't ready for its radical approach. These engines featured technology that made four strokes look antiquated. We're talking about stratified combustion that delivered four-stroke fuel economy with two-stroke power-to-weight ratios. The G2's party piece was its modular design. Major components could be serviced without removing the engine from the boat. The starboard service side meant all routine maintenance happened from one side. The HO high output 150 pushed 150 horses from just 1.9 liters of displacement, a specific output that embarrassed most four-strokes. The direct injection system operated at 600 psi, atomizing fuel finer than morning mist. This precision meant complete combustion and minimal emissions, meeting standards without catalytic converters. The catch? You had to actually do the maintenance. Skip the prescribed break-in procedure, ignore the fuel system cleaning intervals, or use the wrong oil, and the G2 would punish you mercilessly. But treat it right and these engines would run for thousands of hours. Commercial operators who followed the maintenance schedule religiously reported 5,000 plus hours without major issues. Here's what really killed the G2. Perception. The market associated two strokes with smoke, noise, and pollution. Despite the G2 being cleaner and quieter than many four strokes, buyers couldn't get past the stigma. BRP's decision to shutter Evanrude proved that being technologically superior doesn't guarantee market success. Johnson Outboards might be dead as a brand since 2007, but their legacy lives on in the thousands of motors still grinding away on commercial boats across America. The Johnson 150 Ocean Pro, particularly the 1998 to 2004 carbureted V6 versions, achieved legendary status among commercial fishermen. Why? Because these 2.6-liter loop-charged engines were simpler than a sledgehammer and nearly as indestructible. No fancy electronics, no computer-controlled fuel injection, just 6 carburetors, a simple ignition system, and bulletproof internals. The cross-flow loop-charge design wasn't efficient by modern standards, burning 18 to 20 gallons per hour at wide-open throttle. But when you're 50 miles offshore at 3 a.m. and something goes wrong, you could diagnose and fix these engines with basic tools and mechanical knowledge. The Ocean Pro series featured commercial-grade components throughout: stainless steel tilt tubes, heavy-duty lower units with larger gears, and a cooling system designed for continuous high-speed operation. The gear case used a larger 2.0 to 1 gear ratio compared to the recreational 1.86 to 1, providing better load-carrying ability and durability. These engines came from the factory with a break-in oil tank that automatically added extra oil during the first 10 hours of operation. After that, the VRO, variable ratio oiling system, provided bulletproof oil injection when it worked. Many commercial operators disconnected the VRO and pre-mixed their fuel, eliminating a potential failure point. The real testament to their durability: drive through any commercial fishing harbor today and you'll still see faded blue Ocean Pros churning away 2 decades after Johnson closed its doors. Parts remain available through the aftermarket, and any mechanic over 40 can rebuild one blindfolded. Suzuki might not have had the marketing budget of Yamaha or Mercury, but they've quietly built one of the most bulletproof engines in the business with their DF150. This 2.9-liter inline-4 features their second-generation lean burn control technology, which sounds like corporate greenwashing until you realize it actually works. This system monitors exhaust oxygen levels and adjusts fuel delivery in real time, delivering up to 20% better fuel economy than competitors when cruising. But here's the real story. Suzuki's background in motorcycles shows in their engineering philosophy. These engines use a dual overhead cam design with 4 valves per cylinder, similar to their sport bike engines. The offset driveshaft design, moved 60mm forward, reduces vibration so effectively that you can balance a coin on the cowling at idle. This isn't marketing fluff, it's physics. The offset shaft creates better weight distribution and reduces rotational movement. The DF150 features a 2-stage gear reduction system that Suzuki pioneered. Instead of one large gear reduction, they use two smaller ones, reducing gear stress and increasing longevity. The water-cooled voltage regulator might seem like overkill until you realize electrical failures cause more breakdowns than mechanical issues. The controversial bit: Suzuki dealers are scarcer than honest mechanics. When something does go wrong, and statistically it rarely does, finding a qualified technician can be challenging. Parts availability is excellent if you can find someone who knows how to install them. One owner I know learned to do his own maintenance out of necessity, but reportedly only needed basic services over 3,000 hours of operation. At £485, the DF150 isn't the lightest option, but that weight comes from overbuilt components and a massive 5.5-litre oil capacity that keeps internals happy even during extended high-speed runs. Honda entered the marine market like that gifted student who makes everyone else look bad. The BF150 showcases automotive technology that seems almost showing off in a marine application. This 2.4-litre inline-4 features variable valve timing and lift electronic control. VTEC. Yes, the same technology that makes Honda Civics scream at stoplights now helps boats jump on plane. These engines feature boosted low-speed torque, blast technology, which despite sounding like something from an energy drink commercial, actually delivers measurable benefits. During rapid acceleration, blast advances ignition timing and adjusts air-fuel mixture, providing the whole shot of a larger engine. The system adds approximately 17% more torque during acceleration without affecting top-end performance. Honda's lean burn control stretches fuel incredibly effectively during cruise operation. By running up to 20% leaner mixture during steady-state cruising, the BF150 can achieve fuel economy figures that embarrass 115 HP competitors. The engine control module monitors multiple sensors 100 times per second, making micro-adjustments that human carburetors could never achieve. The BF150 weighs 485 pounds dry, comparable to competitors, but features the largest alternator in its class at 55 amps. This means you can run multiple electronics without fear of battery drain. The freshwater flush port is conveniently located, encouraging the regular flushing that prevents corrosion. Honda thinking of maintenance reality, not just performance specs. The downside: Honda reliability comes at Honda prices. These engines cost 15 to 20% more than comparable Yamahas or Mercurys. Parts are readily available but also carry the Honda tax. They're banking on buyers who understand that paying $3,000 more up front might save $10,000 over a decade of ownership. Based on commercial operator reports averaging 4,000 plus hours between major services, they might be right. Tohhatzu is the engine manufacturer you've never heard of that makes engines you've definitely seen. They build private label motors for other brands, including some Mercury models, and their own brand offerings are reliability sleepers that commercial operators hoard like gold. The MFS115 represents everything good about Japanese engineering without the Japanese price tag. This 2.0-litre inline-4 shares its basic architecture with certain Nissan automotive designs, inheriting decades of refinement. The result? Automotive-grade reliability at marine prices. These engines feature one of the simplest electronic fuel injection systems on the market. Fewer sensors mean fewer failure points, and every sensor has a limp home mode if it fails. Here's the inside scoop. Many commercial operators buy Tohhatzu engines and immediately remove the cowling details. They don't want competitors knowing their secret weapon for reliability and value. When you see a workboat with a mysteriously unmarked white outboard churning away dawn to dusk, odds are it's a Tohhatzu underneath. The MFS115 weighs just 402 pounds, making it one of the lightest in its class. These weight savings come from not skimping on components, but from efficient design. The single overhead cam configuration is simpler than dual cam competitors, while still providing excellent breathing. Perhaps most impressive is Tohhatsu's parts support. Despite being a smaller player, parts availability rivals the big brands and prices are typically 30 to 40% lower. The engine shares components with their 75 to 90 HP models, increasing parts commonality. One commercial operator running 6 Tohhatsus told me his entire spare parts inventory fits into a single tool toolbox. Try that with a mixed fleet. Here's where things get really interesting. The next engine on our list has a secret military connection that the manufacturer doesn't advertise. If you're enjoying this breakdown of marine reliability, smash that like button and share with your friends. Now we're entering exotic territory with the OXE Diesel 200 outboard. This Swedish marvel breaks every rule in the box. It's a diesel outboard, already unusual, using a horizontal crankshaft automotive engine, BMW origin, connected to the lower unit via a belt drive system. If that sounds complicated, it's because it is, but the payoff is worth it. Why diesel? Because diesel engines treat abuse like a light massage. The OXE 200 can run on multiple fuel types: diesel, biodiesel, JP8 military fuel, even kerosene in emergencies. The military loves these things because they can share fuel with everything else in their fleet. NATO forces, particularly Scandinavian navies, have adopted the OXE 200 for special operations boats where reliability trumps everything. The OXE 200 uses a 2.0-liter BMW automotive diesel that's proven itself in millions of cars. Maximum torque of 420 Nm arrives at just 1,750 RPM. Compare that to gas outboards that need 4,500 plus RPM for peak twist. This means less stress, lower operating RPM, and theoretical lifespans exceeding 10,000 hours. Fuel consumption runs about 42% less than comparable gas outboards at cruise speeds. The belt drive system eliminates gears in the upper unit, reducing complexity and maintenance. Belts need changing every 500 hours, but that's a 30-minute job versus rebuilding gear sets. The horizontal engine orientation means automotive mechanics can work on it. Try finding that advantage with conventional outboards. The catch? The OXE 200 costs around $45,000 and weighs 577 pounds. You need a transom built like a bridge abutment and a wallet to match. Parts come from Europe, so budget accordingly. But for commercial operations burning thousands of gallons annually, the fuel savings alone justify the price within 2 years. Yanmar builds equipment that starts every time, runs forever, and outlasts civilizations. Their DTOR 111 diesel outboard brings this agricultural reliability to the marine world. Don't let the modest 111 horsepower rating fool you. Diesel torque makes those horses feel like they're on steroids. This engine uses Yanmar's 4LV series industrial diesel technology, a 1.995-liter common rail injection power plant that's proven itself in generators, pumps, and tractors worldwide. Parts availability is essentially forever. Yanmar supports engines decades old because farmers demand it. Maximum torque, 295 Nm, arrives at just 2,000 RPM, providing pulling power that embarrasses gas engines twice its size. The revolutionary feature is the steerable gear case that operates independently of the powerhead. While conventional outboards turn the entire engine for steering, the D-torque keeps the engine stationary and vectors thrust through an articulating lower unit. This reduces mechanical complexity up top and provides unprecedented maneuverability. You can actually walk the boat sideways. The narrow powerhead, just 14 inches wide, reduces aerodynamic drag, and the hydrodynamic gear case borrowed from sailing technology cuts through water with minimal resistance. Commercial operators report fuel consumption 40% lower than gas equivalents, with service intervals extending to 500 hours. Yanmar's obsession with cooling shows in the dual circuit system that keeps the engine at optimal temperature regardless of water conditions. The heat exchanger design prevents raw water from ever entering the engine, eliminating internal corrosion. At 348 pounds, it's surprisingly light for a diesel, though still heavier than gas alternatives. The downside? Like most diesels, initial cost approaches $30,000. The unique design means technicians need specific training, but when Norwegian fish farmers are getting 15,000 hours from these engines in the harshest conditions imaginable, the value proposition becomes clear. Cox Powertrain took a radically different approach with their CXO300 diesel outboard. This British-designed monster uses a 4.4-litre V8 architecture that delivers 300 horsepower while sipping fuel like a 150. But here's where they went completely bonkers. Instead of adapting an automotive engine, they designed a purpose-built marine diesel from scratch. The CXO300 features a unique opposed piston design. Wait, no, I need to correct that. The Cox actually uses a traditional V8 configuration with some innovative twists. The engine block uses compacted graphite iron, CGI, the same material found in Formula 1 engines, providing strength beyond traditional cast iron while weighing less. This attention to material science permeates the entire design. The party trick is the cooling system. Cox engineers created a two-stage seawater cooling circuit that prevents thermal shock while maintaining optimal temperatures. The engine can ingest 90-degree Fahrenheit seawater and maintain perfect operating temperature. Try that with a conventional outboard. This makes it ideal for tropical operations where cooling becomes critical. Perhaps most impressive is the gearbox, rated for over 1 million shift cycles. The lower unit uses Formula 1-derived gear technology with shot-peen surfaces that actually get stronger with use. The propeller shaft runs on dual ceramic bearings that need no maintenance for the engine's entire life. Fuel efficiency numbers are staggering. Cox claims 25% better economy than the best gas 300 HP motors, and independent tests confirm it. At cruise speeds around 25 knots, these engines burn just 7 to 8 gallons per hour. Military contracts. Cox supplies various navies validate the reliability claims with reported mean time between failures exceeding 1,000 hours of continuous operation. At £826 and costing upward of $75,000, the CXO300 isn't for casual boaters, but for commercial operations, military use or serious long-range cruisers. The combination of power, efficiency, and theoretical 8,000-hour service life makes the math work. So which is truly the most indestructible? The most reliable engine is the one that's properly maintained. Even the best motor will fail if you treat it like garbage. Choose wisely, maintain religiously, and any of these engines will outlive your boat. If you made it this far, hit that subscribe button and drop a comment with your own bulletproof engine stories.